All right, guys, so you have your first problem. You need a calculator. This should be in your notes, I believe it's page 3 or page 4 of your notes, where it talks about pH. So it says calculate the pH, and your formula, there's only one formula. Well, actually, there's two formulas that can help you calculate pH. But this one formula actually says pH is equal to. So you're going to use this formula because what's given to you is your hydrogen ion concentration. So if you look right here, you see brackets, you see H plus, and in the formula, it requires negative log and then hydrogen ion concentration. So all you're going to do is plug in a value. So you're going to get your calculator, you're going to hit negative log. You should see a parenthesis sign pop up. You're going to enter in your concentration. Now remember the tip I told you. If your concentration, the coefficient that's before the x, starts with or is a 1, not a 1.2, not a 1.1, a perfect 1, then whatever your exponent is, take away the negative. Whatever your exponent is, it is your pH level. So the first question, the answer is 7. That's without doing any math or putting in your calculator. The second one you would have to, because you have 5 times 10 to the negative 5th concentration value of your hydrogen ion concentration. So you're going to put in negative log, put in 5, and what I do in my calculator, I have a graphic calculator, I hit second and the comma button, which is your exponent, and then put in negative 5. Don't forget that negative. And then you're going to close out your parentheses, hit enter, and what you should get for the second example is 4.3. So pause, check, double check, make sure that's what you got. All right, so now you on your reference table, you have 6 formulas that will help you with acids or bases. So you have pH plus POH equals 14, pH equals negative log hydrogen ion concentration, which we just did practice. Number 3 says POH, that's your power of your hydroxide concentration, and it's negative log hydroxide concentration. Then you have Kw, which is your equilibrium constant, which is hydronium ion times hydroxide equals 1 times 10 to the negative 14. And then you have hydronium ion concentration is equal to the antilog of your pH, or 10 to the negative pH. And hydroxide ion concentration, if you want that value, it's the antilog, or 10 to the negative POH. So you're given pH. Which one will help you get your hydrogen ion concentration? So you have this formula right here. Hydrogen ion concentration is equal to 10 to the negative pH. So you literally, in your calculator, you have 2 ways you could do it. You could put in 10 and then the caret that looks like this. Hold on, let me go back. So you could put in 10 in your calculator, and then you could hit the caret button that looks like this, and then you could put in negative, and it says pH, so 7. Or 7.0. You can do that, or you can hit the second button on your calculator and then the log button. So second log, and then it already does the caret for you, and then you put in 7 and then close out your parentheses. All right, try that. So for the first one, you should have had 1 times 10 to the negative 7. And then the second one, when you go antilog, so 10 to the negative 8.5, you should get 3.2 times 10 to the negative 9. Alright, so I just want to reiterate to you, when you're calculating hydronium or hydroxide concentration, it's negative. So whatever your pH is, make sure you put that negative in the front. Alright? Otherwise, you'll get the wrong answer. Alright, so now moving on. It says, what is the pH and is it acidic or basic? So what's given to you? So you have hydronium ion concentration. What formula will you use to get pH? You have 6 formulas on your reference table. pH is equal to the negative log hydronium concentration. So hydronium concentration does not have to be in scientific notation. It could be an actual decimal number. So you're going to do the same thing. Negative log, put that 0.05, 0, close out your parentheses, and hit equal. The second one, you're going to do the same way, negative log 5.2, but you're going to put second comma, negative 12, and then get your answer. So the first question, your pH was at 1.3, and it said, is it acidic or basic? And it is acidic. The second one, you should have had 11.3. 11.3 on the pH scale is a base. Anything higher than 7 is a base. Anything lower than 7 is an acid. And a perfect 7 is neutral. Okay? So, moving on, POH. POH is opposite of the pH scale. It stands for power of the hydroxide concentration. If you want to find your POH, here's your next formula. Negative log, and pay attention to what's in the parentheses or brackets, hydroxide. So again, it's opposite of the pH scale. So in this case, if you're less than 7, if your POH is less than 7, you're a base. If your POH is greater than 7, you're an acid. And if your POH is 7, it's still neutral. So it's opposite. So here you have the question, what is a POH and is it acidic or basic? So the formula that you would use is going to be this third one. POH, negative log hydroxide concentration. So you're going to put negative log and then put in the parentheses 0.085, close out your parentheses. Now, when you get your POH, remember it is opposite of what a pH is on the pH scale. So when you do that first one, you would have gotten 1.1. 1.1 is less than 7, so on a POH scale, it means that it is a base. The second one, you would have done negative log 2.19 times 10 to the negative 9, close out your parentheses. You would have gotten a value of 8.7, but it is a POH. So if I'm greater than 7 on a POH, I am an acid. All right, just to be confusing. All right, so this says the scales are related. Here's another formula. pH was POH equals 14. That number does not change. All right. So if just going back to hydronium concentration, if I have more hydronium concentration than hydroxide, I'm considered an acid. If I have equal levels of hydronium and hydroxide, I'm considered neutral. If I have more hydroxide than I do hydronium, I'm considered a base. All right? Okay, so every aqueous solution has both hydronium and hydroxide. Acidic solutions have more hydronium than hydroxide. Bases have more hydroxide than hydronium. It's like a scale, right? So this scale right here represents an acid because it has more hydronium than hydroxide, and it will change based off the number of hydronium versus hydroxide. And if I have equal amounts, I'm considered neutral. So it says even solutions that aren't acids and bases, yes, every solution will have hydronium and hydroxide in it if it's made with water. Okay? So water reacts with other water. It makes hydronium and hydroxide ions in solution. Here's water reacting with water to make hydronium and hydroxide ions in solution. All right? All right, so it says, remember water is amphoteric. It acts both as an acid and a base. And this is called self-ionization, which gives us an equilibrium constant called Kw. Hydronium times hydroxide equals 1 times 10 to the negative 14. Here is another formula that you have on your reference table. All right? It's always equal to that. Moving on. So let's try it out. So it says solve for hydroxide concentration, but you have hydronium given to you. Now, I can't use 10 to the negative POH because I wasn't given POH. What can you do to get hydroxide concentration if all you have is hydronium? Well, here's my self-ionization formula. Hydronium plus hydroxide equals 1 times 10 to the negative 14. You have your hydronium, but you want to get hydroxide. They're being multiplied together, so how do you isolate that variable? You divide by hydronium on both sides. So therefore, hydroxide is equal to 1 times 10 to the negative 14 divided by 1 times 10 to the negative 5. And that will give you an answer of 1 times 10 to the negative 9, which is your hydroxide concentration. All right? All right, here's a sample problem. So you're given, if hydroxide is 1 times 10 to the negative 3, what's the hydronium concentration? So you have hydroxide, you want hydronium. So I'm going to use this formula right here. Kw is equal to hydronium times hydroxide, and equal to 1 times 10 to the negative 14. I want hydronium, which I circled. So that means I need to get rid of hydroxide. If I'm multiplying these two, you divide. So in essence, hydronium is equal to 1 times 10 to the negative 14 over your hydroxide, which is 1 times 10 to the negative 3. When you put this in your calculator, you need to isolate you can do it two ways. You can isolate the top from the bottom by using parentheses, or you can use the way that I showed you. All you got to do is put in second comma and your exponent, and you never need to put parentheses. All right? So you should have gotten 1 times 10 to the negative 11. Next question. It says, what is the pH? So you have hydronium and you want pH. pH is equal to negative log hydronium. So all you have to do is negative log, and this answer right here, 1 times 10 to the negative 11, close your parentheses out, and you should get 11, which should have been easy. You don't even need to do the math because it's a 1 in the front. Next question, what's the pOH? So pH plus pOH equals 14. You already have your pH, which is 11. How do you get pOH? You subtract it. So pOH is equal to 14 minus 11, which would be 3. pOH is 3. Then the next question, what am I? Am I acid or a base? So you can look at pOH and take the opposite, or better yet, the best way to determine whether or not you're acid or base is use the pH scale. Remember, if you're less than 7, you are an acid. If you're greater than 7, you are a base. If you're 7, you're a neutral. This is a pH of 11. So therefore, I am a what? A base. All right. Okie dokie. So this page in your packet is similar to that. The only thing that it is missing here, it doesn't have a 1 times for your concentration. It just has your exponent. Well, it has 10 to the negative 5, which is the number after your in your scientific notation. So really this is 1 times 10 to the negative 5th power. Okay, so what you need to do is to determine what the empty spots are. So remember, if the pH is less than 7, you are an acid. If pH is equal to 7, you are neutral. If your pH is greater than 7, you are a base. This right here in the corner is all of your 6 formulas. This fourth one here is hydronium times hydroxide equals 1 times 10 to the negative 14. So it's just the 4 got cut off. And these are just 3, but they're not all of them right here. Okay, so if I want my pH right here, I need to go find what's the formula for pH. pH is negative log hydronium concentration. So in your calculator, what you're going to do, here's your hydronium concentration. So you're going to go is equal to negative log. And then in your calculator, you're going to put in, see that says 10 to the negative 5? You're going to put in 1 times 10 to the negative 5, right? Close out your parentheses. Now remember the tip though. If you have 1 in the front, that means whatever your exponent is your pH. So do you even really need to do the math? No, my pH is 5. All right, so now I have my pH. I would jump to this one right here. Find my pOH, because pH was pOH equals 14. So all you have to do, you have your pH, which is 5. How do I get POH by itself? 14 minus 5 equals what? Is 9. Well, that's terrible. So it is a 9. All right. Hydroxide concentration. Well, I want hydroxide. I could do two formulas. You could do this one right here, 10 to the negative POH.